Hi everyone. Today we're going to learn about something called dimensional analysis, otherwise known as DA. Also, sometimes people think of it as the factor label method, unit conversion, factor analysis. Those all are names for the same thing. I'm going to abbreviate it DA. Dimensional analysis is a strategy that we can use that allows you to change any unit from one to another. It's a really simple way of looking at unit conversion. Because I know some people, sometimes you would have done this in your grade 10 science class, likely in the physics unit, where you have to change from unit to unit, and it gets a little confusing thinking about which way to put your fraction. But dimensional analysis takes all the guesswork out of it for you, and it's just a really straightforward way of doing things. It's based on two things. So number one, the first premise is that you can multiply or divide any quantity by the number 1, and the result is the original quantity. For example, 3 times 1 equals 3. So I multiplied 3 by the number 1, and I get the same number. Same as division, 3 divided by 1 equals 3. And I can use symbols for this too, so heart times 1 equals heart, etc., etc. Okay, so multiplying or dividing by the number 1 results in the original numbers. This is our first premise. The second premise is that the number 1 can be written in different ways. So at this point, if you were in class, I would ask you, you'd be brainstorming for the different ways that you can write the number 1. So some people, of course, would say 1, or we might use French or Latin, or Spanish, uno, or different languages that people might have, but there's all kinds of ways to write the number 1. We can write it like this, of course. I can write it 1 divided by 1. I could write 3 divided by 3 is equal to the number 1. I could do a heart divided by a heart is equal to the number 1, etc., right? So this could go on forever. There are tons of different ways, an infinite number of ways of writing the number 1. So this is important. Now, if we look here, I've got 2 meter sticks. So these are meter sticks. If you can't tell from the picture, whoops, yeah, not working. Sticks, there we go. So meter sticks. So if I held up a meter stick to you, you could identify that as 1 meter. If I chose you to use a different way to describe it, you could maybe say 100 centimeters, right? Those are the same thing. So 1 meter is equal to 100 centimeters. So what this tells me is that 1 meter divided by 100 centimeters is going to be equal to the number 1. So this is the premise that dimensional analysis is based off of, because this is known as a unit conversion factor. So when you have two different units that are equal to each other, so we have different quantities here, of course, making them equal to each other, and if we present them as a quotient or a division here, that is equal to the number 1. So that means that I can use this to convert from unit to unit. So basically we convert units by multiplying by these conversion factors, and we can cancel units until we get to the one we want. And we're going to work through examples for this. Now we're going to stick just with the metric. We're going to just use metric right now, because I want you to get used to learning the prefixes as well. So you would have been given a sheet in class called the metric prefixes. So we're going to use these. So how many meters are in 3 centimeters? So you know how to do this question. The answer is going to be 0.03, but we're going to use dimensional analysis to solve it. And so we've got a standard format for this, and it's going to be, so what you're looking for. So what you're looking for is going to be equal to what you know, and then you're going to multiply it by the conversion factor. So this is your conversion factor. And the unit for what you're looking for is going to go on the top, because you want to end up in that. The unit for what you know goes on the bottom because you want that to cancel. So looking at this, using this example here, how many meters? So I'm looking for meters. So what I'm looking for is meters equals, what do I know? I know 3 centimeters. And then I need to multiply this by the conversion factor. Now, centimeters is what I know, and I want to get rid of centimeters. So I'm going to put that unit on the bottom because I want to get rid of that. I don't want it anymore. Meters is what I want to end up in, so that goes on the top. So that's why that unit goes over there up to the top. So now, what is the conversion factor between meters and centimeters? Now, we just went through it with the meter sticks, right? We know what it is. It's 1 meter is 100 centimeters. So looking at this, 1 meter is 100 centimeters. So this conversion factor, that 1 meter divided by 100 centimeters, is equal to the number 1. So I can multiply it by 3 centimeters. I'm allowed to do that, and I get the same value. So if I look at the units here, they're going to cancel out. Centimeters cancels because one's on the top, one's on the bottom. I end up in meters, which is what I want. So I would just go 3 multiplied by 1 divided by 100, 0.03 meters is my unit. Now, again, this was a pretty easy example. As things get more complex, this system is going to make more sense to use. We'll try this one here. Again, this one's pretty straightforward, but we'll use dimensional analysis for it. So convert 3.2 meters to millimeters. So again, we're going to use our general formula here of what you're looking for equals what you know multiplied by the conversion factor. So what you're looking for is millimeters equals what you know. I know 3.2 meters. Now I'm going to draw my conversion factor. Unit that goes on the bottom is always going to be the diagonal unit here. So what I know has to go to the bottom because I want to get rid of that. So meters on the bottom, millimeters on the top. And now we're going to use this chart. Now these charts can be confusing for people. It's got a magnitude there, right? So what we're going to say is that let me just think, how is this working again? Just give me a second here. Yeah, so 1 millimeter is going to be equal to, and then you find the milli prefix, and it says 10 to the negative 3, so that's going to be 1 times 10 to the negative 3 meters. So 1 millimeter is equal to 1 times 10 to the negative 3 meters. And then I can work that out. So I've got meters cancel. I end up in millimeters, and the answer is going to be 3.2. And then it's going to be times 10 to the positive 3. And then my unit for that is millimeters, right? And you don't have to write this in scientific notation. You can put it out long form. Either one is fine. Okay, so these are the metric prefixes. This is the chart I was talking about. The prefix is in front of the unit and gives the magnitude. For example, if liters is the base unit, we can add any of the prefixes to show magnitude. So milliliters, picoliters, decimeters, megameters, or megaliters, sorry, whatever. So any of the units, any of these prefixes work with any unit. So you'll see meters, you'll see grams, you'll see, like I said, liters, you could see seconds, etc. Okay, it doesn't matter. The metric prefixes work for all of them. Now, so the magnitude is where these are written. You can use that as scientific notation. So you can just write, like we used for the millimeters there. We use the 1 times 10 to the negative 3. I use it in scientific notation just so the math is a little easier to see for people, but you don't have to if you don't want to. Okay, let's just do an example here. So convert 2.4 meters to nanometers. So again, what you're looking for, nanometers equals what you know, 2.4 meters. So I'm going to draw my conversion factor. Meters is going to go on the bottom, nanometers goes on the top. Now, here's where people get confused. And they say, well, where does the 1 go? So if I look here, nanometers, nanometers, there we go, and for the third time, nanometers is this one here, so 10 to the negative 9. So what this chart is saying is that 1 nanometer is equal to 1 times 10 to the negative 9 meters. And meters would be the base unit there. So anything without a prefix, that's considered the base unit. So this is how this chart works. 1 nanometer is equal to 1 times 10 to the negative 9 meters. So if we look here, so 1 nanometer is equal to 1 times 10 to the negative 9 meters. Now, I'm going to follow this through, right? So nanometers, 2.4 meters, meters cancels. I'm left in nanometers. And the answer, you can use a calculator if you have to, but if you think about it, these are just, I can think about it like this. I can think of 2.4 times 10 to the 0 power, right? And if I divide that by 1.0 times 10 to the negative 9, what do I do with exponents when I'm dividing them? Yeah, I subtract them, right? So this is going to be 0, subtract negative 9, which becomes 0 plus 9. So my answer here is going to be 2.4 times 10 to the positive 9. And my unit, nanometers. And you always want to double check for clarity, right? Like, does that make sense? Does it make sense that nanometers, if I have a value in meters and I ask for it in nanometers, that it would be bigger? Yes, that makes sense. Okay, we're just going to do some practice ones here. Now, ideally, I want you to pause the video and try them on your own before checking to see what the answer is. So, again, what are you looking for? You're looking for liters. What you know is 3.1 gigaliters. So, looking at the chart, I got to find gigaliters here. Gigaliters is here, so it's 10 to the positive 9 this time. So what this means is that 1 gigaliter is 10 to the 9 liters. So gigaliters goes on the bottom, the 1 goes here, and then liters up here, and it's going to be 1 times 10 to the 9th. So I'm just going to multiply those out, and I get 3.1 times 10 to the 9. Gigaliters cancels. I end up in liters. There you go. Now, this one's a little different. Now we've got convert 2.3 femtometers to megameters. Now, what's different about this is that there's not a base unit. I've got 2 prefixes. So that makes using our chart a little trickier. So I would suggest, you've got femtometers, and I want to get into megameters. I would first take femtometers and go into meters, and then from there go into megameters. So let's set it up, and I'll show you what I mean here. So I'm looking for megameters equals, I know 2.3 femtometers. So I'm going to draw my conversion factor. And here, femtometers goes on the bottom, meters on the top. So I'm going to go back to my chart. Femtometers is here, 10 to the negative 15. So 1 femtometer is 1 times 10 to the negative 15 meters. So if I were to stop my problem right now, femtometers would cancel and I'd be in meters, but I don't want meters, I want to get into megameters. So that tells me that I need another bracket because I want that meters to cancel. So meters is going to go on the top, megameters is going to go on the, I think I said that backwards, didn't I? Meters is going to go on the bottom, megameters on the top. I'm going to go back to my chart here. Megameters is here, 10 to the 6th. So I say that 1 megameter is 1 times 10 to the 6th. So now I can just use my grade 9 math skills, because you would have done multiplying and dividing polynomials back then, and you would have figured, or exponent laws, you would have done that in your grade 9 math course. And now we can figure this out. So I've got 2.3, now remember, this is the same thing as 2.3 times 10 to the 0, right? So 10 to the 0 times 10 to the negative 15. When the bases are the same, you add the exponents, right? So 0 plus negative 15 is negative 15. Now I'm at negative 15. Now I want to factor in this piece here. I've got positive 6. So negative 15 take away positive 6 is going to be negative 21. So the answer here, 2.3 times 10 to the negative 21. And now I want to go back and I want to check my units, make sure I'm correct. So femtometers, femtometers, meters, meters, they all cancel. I end up in megameters. So my unit here is megameters. So these are tricky, but you'll just get the hang of them the more you do. Let me just see here. Yeah, we're going to do one more example here. So convert 2.4 times 10 to the negative 5. I have Z. What do I have this for? Oh, zepto. Zeptoseconds to petaseconds. Some of these prefixes get kind of weird. So I'm looking for petaseconds equals, I know 2.4 times 10 to the negative 5 zeptoseconds. So I don't have a conversion factor that takes me directly from zeptoseconds into petaseconds. So I'm going to work through the base unit, which would be seconds. So zeptoseconds here, seconds here. I know that 1 zeptosecond, I'm going to look at my chart for this, is 1 times 10 to the negative 21. So 1 times 10 to the negative 21. Now, if I stop the problem right now, I'd be in seconds because the zeptoseconds canceled. But I don't want that. I want to get to petaseconds. So I want seconds to cancel, and I want petaseconds to stay. So that goes on top. So 1 petasecond, using the chart, is going to be 1 times 10 to the 15th. 1 times 10 to the 15th seconds. And again, these numbers, those conversion factors, come from that chart I gave you. So now, looking at this, I can just do the math using my exponent laws. They're all 1, so that's why I can keep that 2.4. So my answer is going to be 2.4 times 10 to the, and now I go, I'm going to use a different color here. I take my negative 5 and I add negative 21, so that brings me to negative 26. So negative 26, subtract positive 15, so negative 26 is going to get me to negative 41. So, oops. Is that right? Hopefully my math is right on that one. So that's going to be negative 41. And then let's check our units. Just going to switch colors here. Zeptoseconds, zeptoseconds, seconds, seconds. And I end up in petaseconds. So that's my unit. Okay, so some of these you have to use 2 brackets then if you have to go through the base unit. If they're just converting to or from the base unit, then it's just the 1 bracket. Exercise 3 is now assigned. I will post the answer key, so make sure you check that out and come to class tomorrow with your questions. Thanks.